Discovery and the Dawn probe. In a groundbreaking proclamation, scientists revealed the existence of a cosmic phenomenon unlike anything humanity has ever recorded in history. NASA, the agency often seen as a pioneer of exploration, celebrated worldwide for pushing the boundaries of the unknown, announced that this celestial marvel is as mesmerizing as it is mysterious. What makes this discovery so captivating is not only its colossal scale and unorthodox path through space, but also the astonishing fact that it seems to emit signals that appear purposeful, as though deliberately crafted rather than accidental. Could this extraordinary revelation be a sign that humanity now stands at the very threshold of truths capable of rewriting our entire understanding of the cosmos? Might it even hint at the possibility of intelligent life existing on worlds far beyond the familiar blue orb of Earth? As scientists pore over NASA's remarkable observations, the sense of anticipation grows. We may be on the verge of deciphering mysteries that once seemed no more than distant dreams, mysteries that feel like whispers carried across the void of space. To probe deeper into such enigmas, we turn our focus to one of NASA's most ambitious missions, the Dawn probe. Launched in 2007, Dawn carried with it not only advanced instruments, but also a new form of propulsion. A set of 3 revolutionary ion thrusters that glowed with an eerie blue light as they fired into the darkness. Unlike traditional rockets that burn bright and then fall silent, these ion engines provided a steady, patient push, a gentle but relentless acceleration that allowed Dawn to achieve feats no other spacecraft had managed before. Its voyage began with a daring objective: to become the first spacecraft to orbit 2 different bodies beyond the Earth-Moon system. The first of these destinations was Vesta, a colossal body that ranks as the second largest object within the asteroid belt. For 14 months, Dawn remained in Vesta's embrace, scanning its rugged cliffs and ancient plains, sending back images of a surface carved by titanic impacts and shaped by billions of years of cosmic history. These images revealed towering mountains higher than Everest, deep canyons scarred by ancient collisions, and surface layers that told of violent beginnings, a reminder that even small worlds can bear the scars of creation. Every transmission, every dataset from Dawn's instruments, expanded humanity's understanding of how the early solar system evolved. But the mission was far from complete. Once Dawn's historic investigation of Vesta concluded, the spacecraft prepared for what many considered the most ambitious stage of its odyssey. It would attempt something no mission had ever achieved before: to escape the gravity of one asteroid belt giant and set course for another, the largest of them all, Ceres. This feat was made possible by Dawn's remarkable ion propulsion system. While its thrust was gentle, it never relented. Hour by hour, day by day, its engines pushed the craft further into the black sea of space. This steady persistence allowed Dawn to break free from Vesta's grasp and slowly arc its way across millions of kilometers, navigating toward a world shrouded in mystery. Conventional chemical rockets could never have managed such a maneuver. Only Dawn's quiet but enduring engines made the impossible suddenly achievable. And so the stage was set. Humanity's robotic explorer, having conquered Vesta, now sailed across the asteroid belt toward its greatest challenge yet: an encounter with Ceres, a dwarf planet whose secrets had remained hidden for centuries. The mysteries of Ceres and the implications first discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres has fascinated generations of stargazers and scientists alike. With a diameter of nearly 950 kilometers, it is vast enough to dominate the asteroid belt, yet still small enough to be classified as a dwarf planet in 2006. For centuries it was nothing more than a blurry speck of light in telescopes, but in 2015, that changed forever. As Dawn drew near, anticipation across the scientific community reached a fever pitch. For the first time in history, we would witness Ceres in crisp, high-resolution detail instead of the hazy outlines captured by Hubble. The first close-up images stunned the world. Ceres's surface was battered with ancient craters, etched with the scars of billions of years of impacts. Yet what captivated everyone's attention were the bright, gleaming spots shining defiantly against the otherwise dark, rocky terrain. Most striking of all was a cluster of luminous areas within a crater, so reflective they appeared to glow from space. Speculation erupted. Were they frozen plains glistening in the sunlight? Were they salt deposits left behind by evaporated brines? Or could they be evidence of something far more extraordinary? Further investigation revealed that these spots were rich in salt-based minerals, suggesting that briny liquid water once surged upward from the depths and then evaporated into space, leaving behind shining traces. This discovery pointed to the process of cryovolcanism, a rare and alien type of volcanism where icy volcanoes erupt with water, ammonia, or methane instead of molten rock. The brightest location, nicknamed Spot 5, showed variations over time, hinting at the possibility of ongoing or very recent cryovolcanic activity. If true, this meant that Ceres was not a cold, lifeless fossil of the solar system's past, but an active and evolving world still reshaping itself today. Ceres's uniqueness lies in its dual nature. It has the rocky qualities of asteroids, yet also the icy, volatile rich chemistry of comets. Its surface contains water ice, clays, and carbonates, while ammonia-bearing compounds suggest it may have originated in the frozen outer solar system before slowly migrating inward. Its interior structure is layered and complex, a rocky core at its heart, wrapped by a mantle of ice and salty water, and covered by a porous protective crust. This design allows the possibility of underground reservoirs of liquid water, hidden oceans that might have persisted for billions of years. The implications are profound. If liquid water exists, then the essential ingredients for life might also be present. Ceres may not only preserve secrets of the early solar system, but also act as a laboratory for understanding how water shapes planetary bodies and perhaps even how life itself can emerge in unlikely places. Through its years of dedicated exploration, the Dawn mission transformed Ceres from a distant speck in the night sky into a world of complexity, activity, and wonder. Its discoveries challenged long-standing beliefs about small worlds, revealing instead a dynamic planetary object that still holds countless mysteries within its icy shell. Even after Dawn's mission concluded, its treasure trove of data continues to inspire scientists, raising new questions that reach beyond the asteroid belt itself. Could cryovolcanism still be active on Ceres today? Might hidden oceans still exist beneath its frozen crust? And could such environments one day reveal microbial life thriving in the dark? These questions remind us of one truth: the story of Ceres is only beginning. What started as a mission to study two objects in the asteroid belt has become a gateway into new possibilities, showing us that even the smallest of worlds can hold the biggest cosmic mysteries.